Hi, this is section 5.1 on angles. So we're starting our chapter on trigonometry. So this first section is on angles. So they want us to draw the following angles. So let's draw that 30 degrees. So this is the initial side that you start with, and you want to go out 30 degrees. Well, the entire circle, one complete circle or revolution is 360, so 30 would have to be approximately about here. And the orientation is this direction, counterclockwise. So that's our 30-degree angle. All right, the next one is 180. So we start with the initial side. And then 180 is it's going to be half of an entire revolution. So it's going to be a straight angle. So it's going to just look like a straight line. And the orientation is also counterclockwise. That's 180 degrees. This is called the terminal side, by the way. Terminal side, initial side, initial side. All right, negative 135, that's going to go in the counterclockwise direction. So we still start with the initial side at 0 degrees. And instead of going counterclockwise, we're going to go clockwise. So this is 90. 90 plus 45 is negative 135 in this case. So we're going to draw our angle about right there. The terminal side will be right in between those two axes. And we're going clockwise this time because it's a negative angle. All right, the next exercise is telling us that theta is 60 degrees in standard position. Find two positive angles and two negative angles that are coterminal. So this word coterminal, that just means that it lies in the same position as the original angle. So what we can do is we would just add 360 degrees and we'll be right back. We'll be in the same position. So let's draw 60 degrees first. 60 degrees is approximately about right here, quadrant 1. So if we go from 60, we go one complete revolution, we'll be right back where we started. So in other words, what you got to do is just take 60 degrees and add 360 to it. And you should get 420. So that would be a coterminal angle. And they want two positive coterminal angles. So now we would add an additional 360 to that to get yet another coterminal angle. And that's going to be approximately, or exactly, I should say, 780 degrees. So those are the two positive ones. To get the negative coterminal angles, you're just going to go in the negative direction clockwise. So you're not going to add 360, but you're going to instead subtract 360. That'll be negative 300. And if you subtract 360 again, you'll get yet another negative coterminal angle. In this case, it'll be negative 660. All right, so that's how you find coterminal angles. So here are some definitions. An acute angle is any angle that's between 0 and 90. For example, 32 degrees. An obtuse angle is any angle that's between 90 and 180. An example of that would be 100 degrees. Complementary angles are angles whose sum is 90. So we can say, 30 plus 60 is 90. Supplementary would be two angles whose sum is 180. So I'll go with 145 plus, 35, I believe, is 180. So these are just examples. There are many others. Okay, so let's look at the next example. They say find the angle that is complementary to theta. So in order to find an angle that's complementary, you need to find a different angle whose sum would be 90. So what we can do is we can subtract this angle from 90 degrees. All right, so if you subtract, you can just use your calculators for this. You're going to get the angle 46.13 degrees. So this angle and this angle are complementary because if you add them up, if you find their sums, it'll be 90 degrees. All right, problem number 2 is a little bit more challenging because as you can see, there's some other funny notation. So this means degrees. This single mark means minutes, and this means seconds. So what you would need to know is that there are 60 minutes in 1 degree, and there are 60 seconds in 1 minute. So for every 60 seconds, that makes up 1 minute, just like in time. And instead of 60 minutes equaling to 1 hour, like in time, 60 minutes is equal to 1 degree. So what we can do is we still need to find a complementary angle to this angle. So we need to subtract from 90 like we did over here, but we have to get a little clever in the way we represent 90 degrees. Instead of representing it as 90 degrees, we can represent it as 89 degrees, 59 minutes, and 60 seconds. Because if you notice, 60 seconds is equal to 1 minute. So if this becomes 1 minute, then you have 60 minutes, and then 60 minutes is equal to 1 degree, so that would bump this up to 90 degrees. So this is just another way to represent 90 degrees. So these are equal. All right, now we can do the subtraction. 12 degrees, 37 minutes, 24 seconds. If you do that, you will get, let's see, I think this is 36. This would be 22, and this would be 77 degrees. So this is the angle that is complementary to that angle. All right, so now there are 2 different ways to measure an angle. You can use degrees or radians. So the relationship is 180 degrees, or a semicircle is equivalent to pi radians. So that's the relationship. And here are the different conversions. 0 degrees is equal to 0 radians. 30 degrees is equal to pi over 6. 45 is equal to pi over 4, so on and so on. All right. We'll get more into this later. So let's see. If theta is equal to 6.3 radians, notice there's no degree symbol. If you don't see a degree symbol, then by default, it's automatically in radians. Approximate theta in terms of degrees, minutes, and seconds. So what we will do is to convert this to degrees, you have to take the radians, I'll just call them rads, you multiply by the ratio that's given to us. There's 180 degrees for every pi radians. And this is always going to be the ratio that you use to convert. The reason I put the radians on the bottom and the degrees on the top is so that I can cancel out the radians. So now we cancel out the radians, and we're going to get 6.3 times 180 divided by pi. So if you do that on your calculators, you'll get 6.3 times 180 divided by pi is approximately, I'm getting 360.963410.9. I'm using all my digits that appear on my calculator. So the way we get the minutes and the seconds is you take the number in front of the decimal, and that becomes your degrees. So far we have 360 degrees. Now we have to take this portion, the decimal part, and multiply that by 60, and that'll give you the minutes. So on your calculators, I would just subtract 360, and that's going to eliminate this, and so your calculator should just have this now hit times 60, and you should get 57 point, a lot of decimals, so that's 57 minutes. Now you have to get rid of the 57, so subtract 57, And now you're just left with the decimal, which is 0.804655944. And multiply that by 60, so times 60. And that'll give you the minutes. I'm sorry, the seconds. So you should get 48.279. But you're only concerned with the decimal, the number in front of the decimal. So this is your final answer. This becomes this when you convert it into degrees, minutes, seconds. Okay. Now we're going to go the opposite direction. We're going to convert this into a decimal. So instead of going from the decimal to the degrees, minutes, seconds, now we're going to do the opposite. We're going to go from degrees, minutes, seconds into decimal. So instead of multiplying by 60, you're going to divide by 60. So this is the way you would do it. It's going to be 262 plus this seconds. Instead of multiplying, you're now dividing because you're going in the opposite direction. And then instead of adding 31 over 60, you're actually going to add 31 over 3600. And that's because when you're converting seconds into degrees, remember the ratio or the equivalence is this. Let's see, 1 degree is equivalent to 60 seconds, and then 60 seconds is going to be 3,600 seconds. So 3,600 seconds is equivalent to 1 degree. All right. All right, so if you type this into your calculator, you will get if you type it in exactly the way you see it, you should get 262 point. They want to the nearest 10,000. So 10,000 would be, this is ones, tens, hundreds, thousands, 10,000s, right? So tenths, hundreds, thousands, 10,000. So we need 1, 2, 3, 4 decimal places. So my calculator reads 2586. 2586 degrees. All right, so that is how you would do the conversion. All right, the next part of this notes is talking about the formula for the length of a circular arc. So if we have a circle, and let's say we have a center, we have a radius. So this is a radius. This is the arc length, S, and this is theta, the central angle. So we have the central angle, theta, we have the radius, and we have an arc. So in order to find the measure of the arc, you would use this formula. The length of the arc is equal to the radius times the theta. Theta, however, must be in radians. So theta must be in radians for the formula to work. All right, and then to find the area of a circular sector, same thing. You can use the same picture. This is the sector. The area of the sector is what I'm shading in. To find that, you would use this formula. And same thing, theta must also be in radians in order for this formula to work. All right, so let's look at an example. Suppose a circle has a central angle theta subtended by an arc 7 centimeters long with radius 4. Approximate the measure of theta. So I'm going to draw the picture. Center, radius 4. We don't know theta. And we do know the arc length is 7. They tell you that. So we know the arc length is 7. We know the radius is 4. Approximate the measure theta in degrees. All right, so in order to do this, we are going to use this formula, S equals R times theta. All right, so we already know, let's solve for theta since that's what we're looking for. So theta is equal to S over R. S is 7, R is 4. So that is in radians, recall. So now we need to convert that into degrees. So we have the first part of the answer, or one of the answers, the radians. Now we need to find the degree measure. So remember, the way you convert from radians to degrees is you multiply by the ratio of 180 over pi radians. You get the radians to cancel out. And so now what you would do is you would multiply 7 times 180, or you can see if you can cross cancel. 4 goes into 180, let's see, 45 times. And then multiply 7 times 45 and divide by pi. So 7 times 45 divided by pi is approximately 100.26. I'm going to round to 2 decimal places. So it's actually going to be 27 if you round to 2 decimal places. And I'm going to change this equal to approximately, because we're approximating. So I want to be more precise or more accurate and change the equal sign to approximately. So this is degrees, this is radians, and that's it. All right, now they want us to find the area of the circular sector determined by theta. So same problem, now we're going to find the area. So let's use the second formula that was given to us, A equals 1/2 r squared theta. And remember, theta must be in radians, so we're going to use 7/4, not 100.27. So let's plug in values. 1/2, the radius is 4 squared times 7/4. All right, well, we have 1/4 cancels with 1/4. 2 goes into 4 twice, and 2 times 7 is 14. So 14. And the units should be squared. So because the radius is in centimeters and the arc length is also in centimeters, this is going to be centimeters squared for our area. And that concludes this